people that are new to the Geek Force, who aren't necessarily audiophiles, they've just happened onto our campaign, and now they're starting to learn a little bit more. They're asking on the forum and asking on the campaign, what's the difference between tube and solid state? And other people who have been in the force a long time and who are audiophiles, they only know you as a DAC designer. So maybe you can talk a little bit about that too.
All right. First of all, from the DAC part, yeah, I'm a DAC designer, but before that, before this popular, high definition audio DAC, before I play a lot of tube gears. I design tube gears, I mod tube gears. I'm a tube roller. I collect tubes because I really like the sound there. So if I want to do something related to tube, it needs to be good.
So, can you show us the difference?
A lot of people ask about the difference about the solid state and tube. Actually, it's a very loaded and very big question. So I don't want to put too much of my personal opinion here, although you know I'm tube lovers. But I want to show you some real facts about how the solid states, how the tube will change the harmonic distortion spectrum and the ratio between the second, what we call event harmonics and even harmonics. So you can see that. Actually, you cannot hear the sound difference from this video, but I think that it's possible. You can see what's the sound, or what's the potential we are looking for the tube or solid state. All right?
Very good.
So let's try this. So here we have again a Geek Pulse without a back panel, and we are tested it. This is a femto clock and the internal amp upgraded version. So let's check the audio precision. Again, this is the input of the audio precision. This is the output. That's it. Very simple. USB input. So we can see here. Let's go to see the THD plus N ratio now. If we limit the bandwidth from 20 to 20K, you can see, wow, right? The number is amazing. You see the percentage is 0.0005. And going to dB, we're talking about -105. It's amazing. But does that mean it sounds the best? Actually, not really. Because this only represents, it's very true to whatever it gets from the digital signal. So from this number, we can say one thing: Geek Pulse FI is very true to whatever it gets from the signal part. So see something else here. We call distortion product ratio. You see a lot of distortions. So beyond this signal, the fundamental signal, you see a lot of some H2, that means second, is third, fourth, fifth, all the way. You see that on the high order distortion and the lower distortion, this is good natural decay, but still have something here. And I'm about to show you when we switch to the tube buffer, you will see something completely different.
So this, we're talking about the fundamental frequency here, and then these are harmonics of the fundamental, which are whole number multipliers of the fundamental. So it's fundamental times 2 times 3 times 4 times 5. Blah, blah.
That's right.
Okay.
All right. So I'm about to switch.
And what did you just connect up?
Okay, I just connect the Geek Pulse output to a tube buffer stage. This tube buffer stage will be the fundamental, not highly fine-tuned version of our Geek Soul tube. But I want to show you something here. See? Wow! The number just dropped from 105 to 80. So it sounds maybe 25 dB bad. If you really test with a lot of audience, their answer will be not exactly. Maybe half of them like it, half of them don't like it. But let's explore a little bit deeper. You see the THD here. Actually, it's not that bad. THD plus N and TH plus without the N means the noise. So that means, actually everybody knows, tube is a little bit more noisier than solid state. But the noise spectrum usually will focus on the low frequency part only. So for human ears, sometimes you cannot hear it. And you hear something, some people call it a little bit warmer on the low bass part. Actually, I contribute that part of it because, okay, it's make people feel a little bit natural. And let's see the spectrum. You can see that although the number get much lower on THD, but the only one contribute the whole thing is the second order of harmonics. So that means it didn't add too much high frequency noise or the distortion to the whole spectrum. So while you hear the difference between the solid state and tube, actually there are few fundamental secondary or third order harmonics only. And it depends on if you like it or not. It doesn't mean that tube is worse than solid state. It doesn't mean that tube is better than solid state. It's different. And I want to show the other thing. Let's see. We're still on the tube. You can see this 7981. Yeah, I will tell you why we need to match the tube later, but let's see the thing first. If we change the frequency bandwidth to 22 kilohertz, you can see the number is 7981. Remember this two number. 3 to 45, still 7981. And switch that again to 90K. See, the number is still 7981. So I think you guys remember in the first video we used the same skill to test the different THD number on different bandwidths. So from solid state, if you make the spectrum, the bandwidth wider, usually you will have a little bit lower THD. But from the tube, you can see that 22K, 45K, 90K, the number is the same. Why? Because the tube will only create the distortion on much lower order. I mean, from the second or the third, it doesn't create that much about high frequency order like a 7, 8, 9, 10, or even higher.
Up into the light harmonics.
Yes, up into light harmonics. Okay, that's one thing I want to show you.
What about the difference between the two channels?
Two
Normally
channels?
we wouldn't want to see that big of a difference between the two channels, right?
Yes. Oh, the other thing, you can see that when we do the solid state, it's precisely that accurate at 105, I remember. The only difference on the single digit. But when you see tubes, even I just do some tube swap or from different brands. For example, on this case, one is Telefunken, one is the Softac. It will show you totally different spectrum of the distortion. So there will be, I think, a significant reason, a scientific proof to help people understand why when they change tube, they hear something different from this point of view. So when you buy tubes for your Geek Soul or whatsoever, make sure you use the same brand, same batch, closely matched for your soul or other tube end. That will help your channel, that is left and right, sound most likely the same. But no matter what, the specs of tube cannot be as accurate as the solid states. That's the truth I want you guys to know. Okay, this is the last thing I want to show you guys. Again, you can see the fundamental frequency here. All the dominant distortion is second, is on 90. For the rest of this, very, very, very low. And in this FFT spectrum monitor, I can tell you, I think I do, I have confidence tell you, this tube will sound very airy and warm because it doesn't have any high frequency distortion. It's dominant by second harmonics.